Problem 15. Mr. Garcia asked the members of his health class how many days last week they exercised for at least 30 minutes. So the results are summarized in the following bar graph, where the height of the bars represents the number of students. What was the question is, what was the mean number of days of exercise last week? Okay, so let's look at this bar graph. So x-axis is number of days of exercise. So the vertical axis is number of students. Okay, so for example, this means only one student exercise one day whole week, and this bar means 3 students actually exercise for 2 days of the whole week. Okay, so it looks like the 30 minutes is useless information. Okay, we just need to focus on the days of exercise. We need to calculate the mean number. Okay, so let's recall mean here is equals to the total of days of exercise for all students divided by the number of all students, right? So let's calculate the total days of exercise, okay, for all students. So here we have just one student exercise one day, and we have 3 students exercise 2 days. Then we have 2 students exercise 3 days. Then we have 6 students exercise 4 days. That is 8 students 5 days. And that is 3 students 6 days and 2 students 7 days. So the total days equals to 1 times 1, 2 times 3 times 2, 2 times 3, and 6 times 4, plus 8 times 5, plus 3 times 6, plus 2 times 7. Okay, so it's 1 plus 6 plus 6 plus 24 plus 40 plus 18 plus 14. Okay, so then we just need to calculate this sum. Okay, so that is 30. So 40, 70, 77 plus 18, 77, 18 would be 5, 95, 14, 109. Okay, that is 109. Okay, so how many students we have, right? How many students? The number of students equals to 1 plus these numbers, you know, we need to add these, okay? So this is 1 student, 3 student, right? 1 plus 3 plus 2 plus 6 plus 8 plus 3 plus 2. So then equals, this is a 10, this is a 10, 15. Okay, 15. So then, 25, 25, sorry. So this is 10, 10, 25. So then mean equals 109 divided by 25. So when we do the division, it's actually equals 4.36. Okay, so we rounded to the nearest hundredths. So the answer is 4.36. Problem 16. 2 trains, a fast one and a slow one, travel from city A and B. The slow one leaves at 8 a.m. Okay, so we have city A, we have city B. So we have a slow train at 8 a.m. Okay. And with the speed 80 mph. Okay. So the fast train leaves like this. Okay, the fast train leaves at 10 a.m. So we have 10 a.m. with a speed of 160 miles per hour. Okay, so the distance between city A and city B is 400. So the distance between city A, 400 miles. Okay, city B. Miles, how far is the fast train? How far is fast train away from city B when it catches up with the slow train? So, okay, so at the first, let's say, at the 10 a.m., the slow train, let's say, is here. So 10 a.m., okay, 10 a.m. So 10 a.m., the fast train is here. So they start as 10 a.m. So then the fast train catch up in the middle somewhere between A and B to catch up the slow train. So basically the fast train needs to catch up 80. Okay, so from 8 a.m. to 10 a.m., so 2 hours, right? So this distance is 80 times 2 equals 160 miles. So 160 miles. So basically the fast train needs to catch up 160 miles. Okay, so because every hour, the speed difference, 160, the fast train, subtract 80 equals 80 mile ph. Every 1 hour, the fast train catch up 80 mile ph. miles, so every hour, 80 miles. So 160 miles, this 160 miles, so needs to divide it by 80 miles per hour. So then it needs to, the fast train takes 2 hours, okay, to catch up the slow trains. Okay, so for 2 hours, how far does the fast train travel? It's 160 times 2 hours, 320 miles. So here is actually 320 miles. So we know total is 400 miles, right? So away from this point to the B, to the city of the B, this point, okay? Catch up to the city of the B. So it is 400. Subtract 320 is 80 miles. So which is B? Problem 17. All of Yan's marbles are blue, red, green, or yellow. 1/3 of her marbles are blue, 1/4 of them are red, and 6 of them are green. What is the smallest number of yellow marbles? So that is MC8 problems. Okay. So, okay, so we have the marbles, blue. So let's just organize the information. Okay, blue, red, 1/4 are red. Okay, red and green. Okay, and yellow. Okay, so we have 1/3 of her marbles are blue. So this is 1/3, red is 1/4, and the green are 6. So we need to know what is smallest number of yellow marbles. Okay, question mark. So first, the hint here is we need to figure out the smallest, the total number of the marbles. Then the yellow marbles, the number of yellow marbles will be smallest. So what is smallest total number of the marble? Okay. Smallest total number of marbles. Okay, so let's look at here. So because, let's say the total number, this is n. Okay, so because we have 1/3 of the blue, so n multiplied by 1/3, this should be an integer. So that means what? That means n is a multiple of 3, right? Then you can have an integer, okay? N multiplied by 1/3 is the integer, okay? Multiple of 3. Same reason, n multiple 1/4 is also has to be an integer. So n is also a multiple of 4. Then these two conditions makes n has to be multiple of 12, 3 times 4, right? So, okay, so let's try. So the smallest total number of marble, maybe it's 12, right? Because it has to be multiple of 12. So let's try the smallest 12 first. So we have 12 times 1/3 equals to 4. And 12 times 1/4 equals 3. Then we have 6. But when we add 4, add 3, add 6, so that is great. That's 13 already. So great than 12. So then we cannot have any yellow marbles, even greater than 12. So this case doesn't work, okay? So it doesn't work. So then we have to try the multiple of 12. The next one number is 24, okay? So then we have 24 times 1/3, it's 8. 24 times 1/4 is 6. Then we have 6 green. So let's add these marbles. 8 plus 6 plus 6 equals 20. So then yellow, we can have 4. So we have 8 blue, 6 red, 6 green, and 4 yellow marbles. So it works, okay? So then because 24 is the smallest total number of marbles, so then 4 is also smallest numbers of yellow marbles. Okay, so the answer is A, B, C, D. Question 18, in quadrilateral ABCD, so we have angle BAD and the BCD equals to 90 degrees. Okay, so 90, 90. And angle ADC equal to 40 degrees. So if AB equals to BC, so what is angle BAC in degrees? Okay, so from the hint, we know angle A, angle B, angle C, angle D, these 4 interior angles, sum of 4 interior angles in the quadrilateral should equal to 360. Okay, so then we have angle BAD is 90, and angle C is 92, and the angle D is 40. So then we can solve for angle B. So then angle B equals to 180, 140. Okay, so we got the angle B. This one is 140 degrees. Okay, so then in triangle ABC, so we have angle BAC plus angle ACB plus angle B equals 180 degrees. And because this is isosceles triangle, AB equals to AC, so then angle BAC should be equal to angle BCA. BCA, yes, ACB is the same, okay? So then we have 2, these are equal, so 2 BAC plus B, which we know already is 140 degree equals to 180. Then we solve angle BAC equals to 40 divided by 2, 20 degree. So then we got the answer 20 degree, which is C. Problem 19. Before Christmas, Austin was going to send greeting cards to 3 friends. After Austin put cards in 3 envelopes, his 4-year-old brother Ben took out all cards, played for a little bit, and then randomly put them back to 3 envelopes. So Austin didn't know what his brother had done and mailed all cards out the next morning. So what is the probability that none of these cards was sent to the right person? Okay, so first let's recall, what is the probability? The probability is equals to number of valid case. The valid case means the case you want to calculate for the probability. So here the valid case is none of these cards was sent to the right person. Okay, so this right person, right? Then number of all the cases. So that's the probability. Okay, so let's see. So if we have, say this is envelope. Okay, we have A, we have B, we have C. Then we have 3 cards, just A, B, C as. Okay, in a right envelope, that's the right order. So then we randomly to put the cards into these 3 envelopes. So how many ways is total ways? Okay, so first, let's calculate how many ways in total. So as we learned about the multiplication principle and the permutation, so then we know this A, so first, so how many, let's just say how many choice for this envelope A is 3 choice, right? Because we have 3 cards. We can A here, B here, C here, 3 choice. So the next step, let's put the card into the envelope B. So at that time, because you put 1 card in the A already, so only 2 cards left. So then you just have 2 choice. So the last card in the C, so then it's 1 choice. So total should be use a multiple principle, 3 times 2 times 1, 6 choices. Okay, so 6 ways. 6 ways we put these cards into these envelopes. Okay, so then what is the ways for none of these cards was sent to the right person? Okay, the ways of none. Okay, ways of none of card, none of cards sent to right person. Okay, so this is 6. So that is okay. So let's think about it. So first, A shouldn't be in the envelope A. So A just have 2 choice. A could have in the envelope B, or A could in the envelope C, right? So let's put A in the envelope B. Then we have B, C, 2 cards left. So C shouldn't be here because C goes to C will be right person. So C has to be in the envelope A. So A in the envelope B, then B in the envelope C. So that's one way. So the second way is A in the envelope C. So then we still have BC, right? So B shouldn't in the envelope B. So B has to be here, envelope A. So C in envelope B. So only 2 ways we can, it's none of these cards that was sent to the right person. So total is 2. Okay, so then the probability we have is 2 ways over 6, total ways, 1 over 3. C. Problem 20. When the young elephant Dory becomes as old as her mom, so her mom will be 28 years old. when the mom elephant was as old as the young elephant, Dory, so Dory was only 1 year old. What is the sum of current ages of Dory and her mom? Okay, so let's draw a diagram. So say Dory is this, the age, current age represents by that, okay? So mom's current age, okay. Okay, so that's mom's current age. Okay, so let's see the difference between Dory and the mom. It's this part. Let's say that is a D. Okay, D is means difference between mom's age and Dory's age. Okay, so when Dory become mom's age, so Dory actually after D years, right, become mom's age. So mom has to be increased by D2, right? So that's the D. Okay, so this is 28. So that means this whole length is 28. Okay, so when Dory when mom become Dory's age, means mom reduce D years, right? So this is a D. Okay, so Dory have to reduce D years too. Okay, so that is a D. So then Dory is 1 year old. So then we have 1 year old here. So let's draw a line here and a line here. So that's D2. So you can see 3D, 1, 2, 3D equals 28. Subtract 1. So we will have 3D, difference between mom's age and Dory's age equals to 28 minus 1. So 3D equals to 27. So D equals to 9. So then Dory's current age is 9 plus 1, right? D equals 9. 9 plus 1 equals to 10. So mom's age is equals to Dory's age, 10 plus 9. The D difference is 19. So Dory's age plus mom's age equals 10 plus 19, which is 29. Okay, the answer is easy.